Welcome back to my channel Radha Maths Classes. Today I am going to explain you question number 23 part 2nd from exercise 6.2 ratio and proportion, and the question is, if a, b, c, d are in continued proportion, prove that a square minus b square into c square minus d square is equal to b square minus c square whole square. Since a, b, c, d are in continued proportion, so a upon b, it is equal to b upon c is equal to c upon d. These three ratios are equal to each other. Let us consider that the value of each one of the ratio is k, c. I am starting, it means this equal to k, this ratio equal to k, and this ratio is equal to k. I am starting from here. That is c upon d is equal to k, implies that c is equal to dk, and this b upon c is equal to k, implies that b is equal to ck. I am putting the value of c from here, that is dk into k is equal to dk square, and this a upon b, it is equal to k, implies that a is equal to bk, and I am putting the value of b from here, dk square into k, it is equal to dk cube, right? So we have a is equal to dk cube, b is equal to dk square, and c is equal to dk. Let this is the equation number 1. Now on taking LHS, a square minus b square, c square minus d square. A square minus b square and c square minus d square means this multiplied by this. Now I am replacing this a, b and c by these values. A means dk cube whole square, minus b means dk square whole square, c square means dk whole square minus d square. Now this d square, d to the power 2 into k to the power, you have to multiply this power by this, that is k to the power 6 minus this d to the power 2 and k to the power 4, 2 to the 4, and here d square k square minus d square, right? Now take out d square k to the power 4 as a common factor. Inside the bracket you will get this, you have taken out d square and there are k to the power 6 and you have taken out k to the power 4. 6 minus 2, k to the power will be left inside the bracket, and here 1. Now take out d square as the common factor. Inside the bracket you will get this k square minus 1. Now multiply these two, right? Now you will get this d to the power 2, d to the power 2, bases are same. Add these powers, d to the power 4, k to the power 4, and this k square minus 1 into k square minus 1. You can write k square minus 1 whole square. This is the value of LHS. Let this be the question number 2. Here you will have to write using 1 because I have used these result over here, right? Now on taking RHS, RHS is b square minus c square whole square. Now the value of b, I am taking the value of b from here, that is d k square whole square minus c, the value of c is dk whole square, this whole square, right? Now this d square and k to the power 2 to the 4 minus this d square k square whole square. Now take out d square, d square is here, d square is here, d square as a common factor, and k to the power 4 and k to the power 2. You remember one thing in your mind, that you have to take always least power, that is k to the power 2. Inside the bracket you will get the d square you have taken out, k to the power 4, k to the power 2, 4 minus 2, that is k to the power 2 inside the bracket, and 1 whole square. Now this, I am going to remove this bracket, this 2 to the 4, d to the power 4, k to the power 2 to the 4, and this k square minus 1 to the power 2. Let this equation number 3. From equation 2 and equation 3, you can see that the value of LHS is d to the power 4, k to the power 4 into k square minus 1 whole square, and the value of RHS is d to the power 4, k to the power 4 into k square minus 1 whole square. It means the value of LHS and RHS is same. So you can say that LHS is equal to RHS, proved. Thank you.